There are three types of cells in the islets of Langerhans. The first one produces insulin, and these are the beta cells. The trigger that causes a release in insulin is a rise in plasma glucose, which is taken up by the glucose transporter Glut-2 and is then metabolized through glycolysis by glucokinase, which has a high capacity for handling the rise in plasma glucose. Thus, the increased uptake of glucose from plasma and increased activity of glucokinase will activate glycolysis inside the pancreas and therefore will increase ATP output in the islets of Langerhans. The subsequent rise in ATP concentrations inside the pancreas due to glycolysis will initiate a cascade of events that will eventually lead to insulin secretion by the beta cells of the pancreas. The rise in ATP inside the cytoplasm of the beta cells will inhibit a potassium-activated channel in the cell membrane, causing membrane depolarization, which in turn causes the increase in calcium uptake and a rise in intracellular calcium inside the cytoplasm, which eventually will trigger the fusion of secretory vesicles containing insulin and their release of their contents into the plasma. Thus, insulin secretion by the beta cells of the islets of Langerhans are initiated by glucose uptake by Glut-2 in the pancreas, as well as its metabolism by glucokinase. Both Glut-2 and glucokinase have a high capacity for transport and subsequent metabolism of glucose derived from elevated glucose in the plasma after a meal.